Now one another example for this can be like 2, 4, 8, 16, 32, and 64 and 128. 256 and 512. You have to calculate the sum of these. This is a GP, and the common ratio will be common ratio, which we denote by R. That would be 4 by 2, or you can calculate it by 8 by 4. If it is a GP, then you have to just see the first two terms. This is 2. So the sum up to 1, 2, 3, 4, 5, 6, 7, 8, 9. Sum of 9 terms will be A, that is 2, R to the power n minus 1 upon R minus 1. So this will be 1022, because 1024 is this, and minus 2 will be 1022. So this is the sum. Fine. Now we will move on to the geometric mean. Geometric mean, also called GM. Fine. Now if let's say ABC are three numbers which are greater than 0 and are in GP. Fine. Now B is the geometric mean of A and C if it satisfies this equation, that B square is equals to A into C. Now this is easy. If you have n geometric means between two positive numbers A and B, let's say G1, G2, G3 up to Gn and then B, then the relation between G1, all these n GMs, geometric means, will be G1 will be A, B by A to the power n, 1 upon n plus 1. G2 will be what? A, fine, which is the first term, A into B by A, that is the division of last upon the first term, to the power 2 by, fine, this is 2 by n plus 1. N will be given to you, fine. So these are the geometric means. Nth geometric mean will be A into B by A to the power n upon n plus 1. Fine. So this is the general formula. If you put n is equals to 1, you will get the first G1. Fine. Now harmonic mean. The next topic, harmonic mean. Harmonic mean. Let's say if A, B, C are in HP, which is the harmonic progression, so they are in HP, then B is the harmonic mean of A and C if B is equals to 2AC by A plus C. Fine. This can also be written as 2 upon 1 by C plus 1 by A. Fine. This implies, well, first of all, let me tell you about this. If ABC are in HP, this implies 1 by A, 1 by B and 1 by C are in AP. So the reciprocals of these terms will be in AP. If the reciprocal of these terms is in AP, then these terms will be in HP, that is harmonic progression. So we define this by 2 upon 1 plus 1 by C plus 1 by A. This can also be seen as 1 by, you can write it as, let me write it in another way. Let's say it is given to us that B is equals to 2AC by A plus C. So we write 1 by B, that is reciprocal of the left hand side, as A plus C upon 2AC. This can be written as 1 by 2C plus 1 by 2A. This can be written as 1 by 2, 1 by C plus 1 by A. Fine. Or this can be written as 1 by C plus 1 by A upon 2. So that means 1 by B. The second term is the mean of the first and the last term. So this gives you that 1 by A and 1 by B and 1 by C are in AP. So that's why A, B, C are in HP. This is defined with an AP only. Okay. So if A, B, C are in AP, then 1 by B, 1 by A and 1 by C will be in HP. And if A, B, C are in HP, then 1 by A, 1 by B, 1 by C will be in AP. So we were reading about harmonic mean. So let's discuss that. Harmonic mean H of A1, A2, A3 up to AN is given by 1 by H is equals to 1 by N. This is just like the arithmetic mean of 1 by A1, 1 by A2. Fine. 1 by A1 plus 1 by A2 plus 1 by A3 plus 1 by A4 plus 1 by AN. So this will be your harmonic mean. Fine. For two terms you can see that 1 by 2, 1 by A plus 1 by C. This was 1 by B. We wrote this. So that's how we get this formula. Okay. Now relation between arithmetic mean, geometric mean and harmonic mean. That's the most important in this chapter. And let me write it with green. The G square is equals to A into H. This A into H. Fine. Where A is the arithmetic mean, G is the geometric mean and H is the harmonic mean. AM, that is arithmetic mean, is greater than equals to geometric mean is greater than equals to harmonic mean. And this, when will these be equal? AM will be equal to GM will be equal to HM if and only if A1 is equals to A2 is equals to A3 is equals to all the n terms are equal, then AM will be equals to GM will be equals to HM. Fine. Now this is the most important inequality between AM and GM and HM, because they can give you like let's say they can give you a question like you have to find the minimum of these numbers A1, A3 and A5, the minimum value of these numbers. Now as we can say that AM is greater than equals to GM, so we can write it like A1 plus A3 plus A5. The product is given, of course, right? Their product is given. A1 into A3 into A5 is given to you. So upon 3, that will be your arithmetic mean of these three numbers. That will be greater than cube root of GM. That will be A1, A3, A5. So if this is given to you, you can find the minimum value of this expression. This was asked in recent JEE 2011, I guess. The question was A1 and it was A, then 3 by A. As the product is constant, this should be constant in that case. Then only you can find the minimum value. Because if this is not constant, this is a variable, then you cannot find the value for this expression. So they must cancel out each other in any way. Like the product of these two is 3. A got cancelled out. So that just like that you can apply these two also and these two also. Fine. So this is important. Then G square is equals to H is important. And this is not that much important because if you know this one, then you will know this one too. So this was all about the means. Now we'll see something which are important results with respect to this chapter of sequence and series. So the first important result is summation of AR plus minus BR. That will be summation of AR plus minus summation of BR. And R will be of course from 1 to N in all the cases. This is important. Second one, let's say AR is the rth term of some expression, BR is the rth term of some other expression. Then you can always write it as, you can always break it. Okay, now if you have something constant inside a summation, let's say KAR, and R is equals to, K is a constant here, so R is equals to 1 to N, then this can always be written as K can be taken outside and AR can be sum up from 1 to N, R equals to 1 to N. Okay, so you can take the common out of the summation. Third property, it is summation of k from r equal to 1 to n. What it will be? Nk, because this is k into 1, k can be taken outside, and 1, if 1 is summed from 1 to n, then it will be n times. Okay, 1 plus 1 plus 1 plus 1 up to n is n. So this will give you nk. This is, of course, k is a constant here. Fine. Now, the next property, fourth one, that is summation of r will be 1 plus 2. That will be r equals to 1 to n. So r equals to 1, r equals to 2, then plus r equals to 3, plus up to r equals to n. So this summation is given by n plus 1 by 2. Fine. You have to remember this one because it is used in many cases. You can take something out and this expression you will see there, and you can directly just put this value. Fine. By just saying the value of n, that where it is, ending. Then fifth one, it is about summation of r square. This is also important. R is equals to 1 to n. This summation series is 1 square, then 2 square, then 3 square, and up to n square. So you have 1 square plus 2 square plus 3 square plus up to n square. That will be, summation is given by n plus 1, n plus 2 by 6. 2n plus 1. This will be 2n plus 1. n plus 1, 2n plus 1 by 6. So this factor is common. You can divide this 6 as 2 into 3. So this factor is the summation of first n terms, and this factor you have to multiply 2n plus 1 by 3 to get the summation of r square. Then sixth one will be summation of r cube, which is also important. These formulas are important because they are directly asked in JEE. Not asked because you can directly apply them. This will be 1 cube plus 2 cube plus 3 cube plus up to n cube, and the summation of this is n into n plus 1 by 2 whole square. That is the sum of first terms, whole square of that. Okay, now the last formula in this case is not that important, but you can always use it to prove other things. AIAJ, where I is always less than j, is equals to 1, fine, up to n, fine. This can always 2a1, a2 or a1, a2, a3, a3, a4, a4, a5. This can always be given as a1 plus a2 plus a3 plus an whole square minus a1 square plus a2 square plus a3 square plus a4 square plus up to an square. Fine. This. So this is one also not that much important, but you can write it. It's like a plus b whole square minus a square minus b plus b square. That will be your 2ab. Just like that. Right? So this is derived from this property only using mathematical induction. And so these are 7 important results which you have to remember before appearing to IIT. Now here we complete our sequence and series. Now we'll continue with continuity and differentiability.